Hi, welcome to my second tutorial about creating and distributing Python packages. In this tutorial, I will explain two options to write unit tests for Python projects and how to run and debug them in PyCharm. As I said in my previous tutorial, this is a part of a series in which I will explain how to create Python packages and configure a project in Azure DevOps and publish the package in Python package index. In this tutorial, I will describe the following: how to write tests using the built-in UnitTest module and PyTest framework. I will show how to code and debug them in PyCharm and how to use test discovery. To demonstrate, I will use a project I recently published in GitHub. It's an implementation of key value pair-based configuration for Python applications. It's a library freely inspired by .NET Standard Microsoft Extensions configuration. So it sounds really complicated, but it's about having a way to read configuration from different sources, which can be dynamically configured. So for example, the production environment has different settings than test environment or development environment. I really like the .NET Core implementation. I mean, the library that I can use when I use .NET Core. So I decided to write something similar in Python. And the project I published in GitHub already contains test. And in this tutorial, I'm going to show from zero how to add one, how to test to such a project. So I created a copy on my local file system without this folder. I will start by adding test using the UnitTest built-in module and then switch into PyTest framework. For the tutorial, I'm going to use PyCharm Community Edition. So I will start PyCharm. Before opening my project, I want to create a Python virtual environment. That's because PyCharm will automatically use it if it is existing already. I'm doing this because this library requires a dependency, which is needed when running test. This dependency is PyYAML, which is a library to read and write YAML files with Python. So since we are going to run test, we need to install the dependencies. So let's activate this environment and install PyYAML. Perfect. So now I will open a project. It is inside projects, tutorials, and here. Now, if everything worked, PyCharm should already use this Python virtual environment. We can verify by going to Settings, Project, Interpreter, and yes, PyCharm was smart. I already read this existing environment as the project one, which is fine. So I already started adding a test, but I will do it again. So now I will add first test. The source code, as you can see, is not huge, but there is surely something to be tested. So let's start adding a Python package, which is a folder, and a module, which I will call with a name that starts with test underscore. This is important because then test discovery will work. I will show you in a while. Now I will first import UnitTest, which is the built-in UnitTest framework in CPython and available also in other implementations of Python. It's inspired by JUnit. Then I will import from raw configuration import configuration, which is the class I want to test. For now, I will create a dummy test so I can show you something. First thing, how to create assertions in the UnitTest framework. You need to call the methods of this class, base class, of others which are available, but in general, when we start using UnitTest, we start from the test case, which is the simplest one. So assert equal, and for now let's put 1, 1. Okay. Now, since we use this naming convention, test underscore, and a class with name test, and a module with name test, we can use test discovery. So when we run the test, we just need to open a console. Be careful because we need to use this environment with the dependency installed, and I can write Python module UnitTest. This is sufficient to run the test. If you want to see more information, we can use also the verbose flag, which will print the name of the test being executed. So if we add more tests, and I will just call it A, B, and C, they will be all executed, right? So if I break one intentionally and execute again the test, I will see this kind of error, which is an assertion error. Okay. So one of the things I want my configuration class to be able, as I wrote in the docstring, to be a read-only facade that let navigating configuration objects using attribute notation. It means that I want to be able to read data which is inside this configuration class as using attribute notation. So I will show an example. So let's call it test attribute access. I will delete this garbage for now. We create an instance of this class. Then this class, as you can see from the IntelliSense, has method add map, which lets add you a map. So a Python dictionary is a mapping object. We can say A is true and B is false, right? Now the assertion would be asserted config.a. This is accessed by attribute notation, whereas this would be dictionary notation. So as I said, config.a expect to be true in this case, and config.b should be false. Okay, let's run it. I will show later how to run it from here actually. So let's run it from command line as we did. It's fine. It means that it worked. If I changed something here, like accidentally put in twice config.a, it won't work, right? And it will fail at this point. And this would be like arrangement, and here actually act at this point, and assertion. So act and assertion. You don't have to write these comments, of course, but just to be clear, I assume that you know what unit tests are about. If not, I invite you to check it on the internet. Let's add now a test to say, for example, overriding values. I expect this class to be able to override things. So test override values. and I create a new one. Now I want to override a value with another map. This time I say that B must be true. And add a new one. Actually, no, let's keep it simple. Now, before B was false after this first statement, now I expect it to be true after this one. Because I'm overriding the values. I expect this configuration class to support overriding previous values by adding several layers of sources. Right now I'm keeping it simple with add map, but it supports also YAML files and ini files, as I said previously, so I will show you in a second. Now I will run tests in a different way. I will actually right click on these things and say to ask PyCharm, please run test in this folder, in this module. And it worked. PyCharm took care of running the test I wanted to run, and I have this nice summary on the left, bottom left. What I could also have done, if something went wrong, to debug them. So I put a breakpoint. Now I can go inside with F7 and see that I'm simply cycling through the items and altering the dictionary of this class. Pretty simple in this case. And again. Now, since I'm cycling through the items, I'm sure that I'm not overriding the A, but this is something I forgot to add in the assertion. So I want to also assert that A didn't change with this second action. And it worked. So this is good one. Now let's say I want to test loading configuration from a JSON file. I will add a test JSON file. And let's say hello world and something good. So now I will add a test to verify that my class can read from JSON sources. And again, as you can see from the IntelliSense, of course I knew the names of these methods because I was the one writing them. This would be the case usually, that the one writing the code knows which code needs to be tested. Sometimes there are testers who are writing code for other programmers, but generally speaking, I saw at work that the same programmer who writes the code also writes UnitTest for it. So now you may be wondering, how should I write the file path to this test JSON file I just added? The proper way to do it in Python is to import a file called package resources actually. And we can get a file path this way. So test file path. Resource file name, the name of this module, which can be obtained this way, and the relative path to this file, so 01.json. Now, if the file path is right, configuration .json file will read this configuration, so we can assert that config.hello will be word and config.something will be good, because we added something good and hello world to this JSON file. Let's see if it works. Okay, it worked. So we can also debug to verify. The values were read properly from the JSON file, and the path is right. Inside this configuration class, actually the instance of this class, and this is another test. All good so far. Now, something that you commonly need to know when you write tests in any framework is to assert exceptions. In other words, you want your libraries or code to raise some exceptions in some situations, and you generally want to test for these exceptions. So let's see how to do it with UnitTest. In this case, for example, I want to make sure that when I try to read a setting which is not configured in the instance of configuration class, I get a key error. So test raises key error for missing setting. Of course, only when I try to read the setting. To make it faster, I will just copy paste a portion of code. Actually, I don't need to add any map. So let's say using UnitTest framework, you need to use this syntax. Assert raises, key error, and as context, config dot something. So this code demonstrates that if I try to read something which is not configured, I will get a key error exception. Let's try it. It worked. Now, something that I recommend you first is to always use the specify the type, which is concrete type, not too generic, and to write assertions also for the error message, so that it is always user friendly. In this case, I want to get information that the setting is missing with this name. So I'm raising configuration setting not found, colon, the name of the setting I'm trying to read. So let's do it this way. First, I need to debug because I don't recall where this message is stored inside the context. By the way, I'm assuming that the people who are following know the syntax in Python. It's quite basic knowledge in Python and Word. So let's add a breakpoint and check how does it look like. So context, here we see it's an instance of assert raises context with a reference to the exception that was risen. And we can check also how does it look, the string representation of this exception. Doing evaluate expression, I right click it. You can do string context dot exception. And it looks like this. Now, this is something curious about the key error, which is always wrapping the value inside the columns, because it's assuming that you want to describe the key which was missing. So maybe we are not making a proper use of the key error exception. We should only write something in this case, but I want the error message to be user-friendly, so I would prefer to keep configuration setting not found. But this is something we need to take into account when writing the assertion. So let's continue. This way. Context, actually, sorry. Now let's try if it works. It did. So now we have a test that verifies that when I try to read something which is not configured, it will throw exception. Since UnitTest framework is inspired by JUnit, there are also other methods apart from self-assert equal. So for example, there is assert almost equals to test probable things, assert count, false, greater equal, is instance, is none, is not none, this kind of stuff. So I'm not going to show all of them, of course, but I will go into another topic, which is parameterizing your test. So really often you need also to have some kind of parameterization of your test. So for example, let's say we want to make sure that types are handled properly by this configuration. So we could have a array in this case. So values, we could have integer, then some float, string, and let's say an instance of datetime. I actually imported something. The module, I want to import the class. Now it looks weird, but in Python the module is called datetime, and the class inside you have datetime, date, time delta, for example. So when you want to actually use the datetime as a class, you need to write from datetime import datetime. So datetime.now, and let's say something, and then the expected types, int, like float, string, and datetime, and for value in values, I need to create an instance of in this case I will use add value, which I didn't show previously, but is simply adding a exact name to the configuration object, and then I will say self assert is instance, expected types. Now I need an index, so it can be something like this. You see, it's not ideal, but I will show a better way to do it later. So now I expect these things to be right. I made a mistake, of course I need to write the name here, which is fine. I also used the wrong order here. And it's fine, it worked. So it means that 1 was kept as an integer, 5.4 as a float, something as a string, and datetime as a datetime. Now, this is not optimal, of course. A better way to do it would be to have something like a decorator, for example. Now I'm writing code that doesn't work. But you get my point. Something like I want to see value, expected type. Okay. Now with UnitTest framework, this is not supported. You need to install some dependencies. You could write your own code that does it. It's not so complicated using functions decorators, but then you need to test also the test code, which is not optimal. It would be best to install a dependency. Now, this is one of the main reasons why I'm not a big fan of UnitTest framework. I like it because it's fast, it works nice, but I prefer the PyTest, which I'm going to show next. So let's try to rewrite this test using PyTest framework. I already opened a browser tab to this framework homepage. You can find documentation here, and it's like pytest.org. As it says, it helps you write better programs according to the authors, of course. So one of the main differences compared to the UnitTest framework is that is that it supports the assert keyword available in Python. So you don't have to write self-assert something. For example, you get assert a value equal expected value. Now, you also have auto discovery, like in UnitTest. I will show later how to use it. And you get extra features like, for example, the parameterization of the test. So, since PyTest is not available in the default installation of Python, we need to install it as a dependency, which is an introduction for another topic I am going to introduce you. So we need to install pip install PyTest. Now we have installed the dependencies for PyTest. And now this is something important. In the setup PyI, we have the dependencies which are needed to install this package. We shouldn't list PyTest here because not everybody wants to install our package, needs necessarily to use PyTest. The tests for this library are more to demonstrate that the library works. So what I recommend is to create a requirements file, but do not call it requirements. To call it, for example, dev requirements, like this. Pip freeze, which will show you the packages we just installed. And we can, as I said, dev requirements, prepare a file like this. PyCharm takes a while to load it. Okay. Now, in my case, I have this package resources with 000. This is a garbage, should be removed. It won't work. So now everybody who check out our repository can install these dependencies like this. Pip install -r and dev requirements. So in such a way, the requirements for development are installed only for developers when you want to install them. Now that we installed PyTest, let's get rid of test we wrote previously. Almost everything. So we can do import PyTest. Now we can either create a use a function directly, like test, I will first show you how to use test discovery. So we can go to view, terminal. It's already here. I need to clean up a bit. PyTest. It's sufficient to run the discovery. It worked. Now let's say we want to debug it. It will be slightly more complicated because, as you see, it didn't work this way. We need to go to edit configurations, click on plus under Python test and say Python test PyTest, and it's fine, this one is fine, and we say, for example, our folder with tests. Apply. Now we can debug this configuration. I always forget to add a name, so it's always unnamed. I go back to edit configuration, I put a PyTest. Apply. Okay. then when we do run debug, it should work. Hurrah, it worked. So I showed how to debug PyTest test. I mentioned previously that one of the limitations of UnitTest framework is that it doesn't let you parameterize your test. So let's see how we can write a better version of the function we created previously to test the types. So test and link types, value expected type, and let's say it's okay. And of course, I need to define the parameters. So pytest.mark.parameterize and arg names. So it will be value expected type and arg values. So let's put let's use a list just for clarity. Here we can use a tuple. So let's say something, I expect it to be still a string, 1 to be still an integer, 4.5 to be a float, and like date time .now to be date time. I need to from date time import date time. So let's see how it works. PyTest framework will call several times this test function for us. So the first time it's something, expected value string. Next time 1, 4, 5, date, and it worked. So the test was succeeded. And as you can see, it's much better than before. To not repeat myself and to not be boring, I'm not going to write every example here in PyTest because I have already something ready in GitHub. So we just show you the code in the GitHub project. And you can see there is the syntax to assert exceptions in PyTest. Similar, it is using also context. So with PyTest raises exception type as exception raised with the action that must cause exception. And here I added also other test for other features of my library. So it's there are about 25 tests. It's enough for this small library for now because I just published a few days ago. So it's okay. Now that we saw how to prepare tests for our Python projects, we are ready for more interesting challenges. In the next tutorial, I will show how to create a project in Azure DevOps, configure a Git repository in it, and continuous integration builds that we will use our test to verify that everything is working after a code change. Even if we are using Python, consider that these concepts apply the same for other programming languages. At work, for example, I always use .NET and .NET Core. But in my private time, I prefer to use Python. So for this tutorial is everything. Thanks for watching and see you!